Hello everyone, welcome back to this fast track revision series of UGC NET Electronic Science. So in this video we'll discuss about the basics of SR flip-flop. Okay, so what I mean by basics of SR flip-flop is we'll confine ourselves to truth table and understand different concepts regarding these flip-flops. Okay, so in the next video I'll discuss about excitation table and characteristic equation. Right, if you are first time to my channel, please consider subscribing. Right, so we know that flip-flop is a bistable multi-vibrator. Because it will have two stable states, that is it can store either 0 or 1. So that is why it is called as bistable multi-vibrator. So SR in SR flip-flop stands for set and reset. Okay, set means making the output is equal to 1. Reset means making the output is equal to 0. So if you are saying the word set means you are going to make the output as 1, and when you are saying the word reset means you are making the output as 0. Okay, so I'll write the truth table here. Truth table. So I'm not going to prove anything because it is the revision series. Okay, so SR and Qn plus 1. So when S is equal to 0 and R is equal to 0, then Qn plus 1 is equal to Qn. Now understand what is the difference between Qn plus 1 and Qn. Okay, so Qn plus 1 is called as next state and Qn is called as present state output. Present state output, next state output, to be precise. Okay, suppose you are applying some input. Let us say S is equal to 0 and R is equal to 0. This is the input which you are applying at 9 AM. Okay, so in the morning now today you are applying S is equal to 0 and R is equal to 0. So you'll get some output, that we don't bother about that. So before you are applying at 9 AM these inputs, okay, so I have used that same when you are applying here at 9 AM, but I have used the same flip-flop which you are applying or which you are using now at 8 AM, and I have given S is equal to 1 and R is equal to 0. So this is the previously applied input, right? So this is the output which I have applied at 8 AM. So I will get corresponding output, right? So correspondingly I'll get Q and Q bar values. Based on the input you will have the change in output. Right, so when you are applying your inputs at 9 AM, now these becomes your, so this Q and Q bar, which is the outputs due to previously applied inputs. So these becomes now your present inputs. Sorry, present outputs. So that what I have discussed here, and we are representing it with Qn and Qn bar. So with respect to the present inputs, these are called as present outputs because they are already there at the output, because flip-flop is 1-bit storage element, 1-bit memory storage element. So it can store 1 bit. Okay, so due to previously applied input, that is S is equal to 1 and R is equal to 0, the outputs which are obtained will be stored by the flip-flop. Okay, so those outputs are called as present outputs with respect to the present inputs which you are applying, these inputs. So we'll represent with Qn and Qn bar, and due to these inputs, now you are changing the inputs. Now the inputs are being changed, so you'll get corresponding change in outputs. So those outputs are represented by next state. So we represent it with Qn plus 1 or Qn plus 1 bar. Okay, so I hope you have got the idea of what is present input and next state output, present output and next state output. Okay, so when S is equal to 0, R is equal to 0, so whatever the present output will be there, that will be equal to the next state output also, that is Qn plus 1 is equal to Qn. There will be no change, so that is why this condition is called as no change condition. When S is equal to 0 and R is equal to 1, output is 0. So this is called as reset condition. As I have told you, when you make the output is equal to 0, so it is called as reset condition. So when S is equal to S is equal to 0 and R is equal to 1, so which output you are making 1? Reset output. So what is reset? Making the output is equal to 0. So you are making the output 0. So Qn plus 1 is equal to 0. Similarly, when S is equal to 1, R is equal to 0, the output is 1, because so for which input you are giving 1? So for set input you are giving 1. So you are setting the flip-flop, so the output is going to be 1, and that condition is called as set condition. When the input is 1 1 for S is equal to 1 and R is equal to 1, the output is indeterminate, which is a don't care condition. So why it occurs is when S is equal to 1 and R is equal to 1, you will get the same values, that is either 0 or 1, same values for Qn plus 1 and Qn plus 1 bar. Okay, so next state outputs Qn plus 1 and Qn plus 1 bar will have the same value, but it is not possible practically because Q and Q bar are always complement to each other. Okay, so that is why we'll take that output, we'll take that case output as don't care condition, and we'll call that as indeterminate condition. Very, very important. Okay, so indeterminate condition occurs when S is equal to 1 and R is equal to 1 in SR flip-flop. Okay, so each and every point which I have discussed is very important, so keep that in your mind. Okay.